called a Schlenk line. The purpose of the Schlenk line, like from a chemistry perspective, is to be able to connect a sample, usually in an R&B flask or in some sort of flask. You need to, in order to vacuum out the air from your sample and introduce an inert gas in order to prevent oxidation of your sample during a reaction. This is often done with like metal chemistry, if you're trying to make like chelates of specific metals where oxidation is an issue. Those reactions usually need to occur under inert conditions. But you also might just want to vacuum out air for other purposes. So we sort of hook this Schlenk line up so that it can be used for a multi-purpose setup. The issue is that it needs to be maintained very carefully for it to be used for all of its applications. So if you're just going to use it for vacuuming, it doesn't require a lot of, maintenance. But if this were to be used for a chemical reaction, in which case you'd be adding inert gas flow to prevent oxidation, you would want the vacuum pressure to be as low as possible. And you would also want to make sure that the gas coming in is dry, because water is also a concern for the reactions that you generally want to do under a Schlenk line. So if you look here, we have two connected manifolds. One is going to be a vacuum line, and one is this is labeled nitrogen, because it's usually nitrogen that we hook this up to. But it can be argon, it can be really anything hook this gas line up to. So let's start with the vacuum line. Over here is the vacuum pump. On and off switch is right here. The inlet is hooked up to this thing right here. What this is a solvent catch. So when you vacuum things through the vacuum line while hooking up your sample through this tube, what will happen is solvents will, just like in the rotovap, they will be collected and vacuumed into the pump. But lots of organic solvents are gonna damage the pump, and pumps are pretty expensive. So what you want to do is have some sort of cold trap here to collect highly volatile solvents. So if your solvent is very volatile, what you can do is you can get maybe a beaker or some sort of container that looks like this, and you place some sort of coolant inside. It can be water, it can be ice water, it can be liquid nitrogen. And what you do is you stick it on a platform and you submerge it. And that way you're capturing all the solvents that you're vacuuming from your sample, and you're preventing them from getting into your pump. If you're using liquid nitrogen, you have to be careful and ensure that you are emptying this every time you use it, because liquid nitrogen is cold enough that you can actually capture oxygen here, and that can be an explosion hazard. So make sure if you're using liquid nitrogen to cool your solvent trap, that you're always making sure that you remove the cold bath after you were done, so you don't keep trapping oxygen there or some other solvent in a critical volatile state. Okay, so you have the vacuum line hooked up to your solvent trap. The vacuum line is hooked up to a vacuum line tube manifold here. In order to vacuum a sample, it needs to be connected to one of these tubes. In order to vacuum, the gas line needs to be closed, and all other tubes also need to be closed. In order to make sure that is true, you can see that these valves screw in and out, or the reverse of that, out and in. So you can actually see if they're open or closed. So you just visually check whether or not they're all closed, except for the one that you want to be using. In this case, I'm using. So you can open the one you want. If the gas line is open, you're vacuuming gas out of the gas source, and you're not vacuuming your sample. So, one of the ways we desiccate and vacuum dry things is by using a vacuum desiccator. So you can have a sample inside a round bottom flask or any other type of sample that fits in your vacuum desiccator. What I can tend to do is put it into a holder. You can stick that in your vacuum desiccator. Now, this rubber seal is important so you can actually have a vacuum seal. What you can also do is grease that rubber seal for a better vacuum seal if you're having trouble, or if this is starting to age. You close that, you attach the vacuum tube, and now your sample is ready to go. So all you have to do is make sure all nine of them are closed. You start up the vacuum by turning it on, and you slowly open the vacuum line. Once you stop hearing this, you can open it up fully. And now this is under vacuum. To turn it off, you can close this. Now this is still under vacuum. You can turn off the vacuum pump. This is still under vacuum, and then you just slowly release the pressure. Okay, now, if you were doing a reaction where instead of releasing the pressure into the open air and letting air rush into your sample, you wanted to let inert gas rush into your sample, what you would do is, upon vacuuming with a sufficient quantity of time, is you would slowly open up the nitrogen. So once that's open, it would be nitrogen flowing into your sample. Once the pressure is sufficient, which you would control at the using the pressure gauge, which is right here. The gas line is connected to this pressure gauge. You would connect this to any gas source that you want, and just make sure that the pressure is sufficient for the application you want, whatever head pressure you require for your reaction. This line is hooked up to this dryerite. This dryerite column is just there to dry the gas to make sure there's no water content, and then it's connected to the gas line here. So once you fill it, you can close the gas valve. And now this is under nitrogen gas. And then you can either keep it that way, or you can, once the reaction is done, you can, it really depends on what you actually want to do with this. But that's how you would alternate between inert gas flow and